Gravity is a force that pulls things towards each other. It's why apples fall from trees and why we stay on the ground. We can't see gravity, but we can feel its effects. Every object in the universe, big or small, has gravity. Gravity depends on two things: mass and distance. Mass is the amount of matter in an object. The more massive an object, the stronger its gravity. Distance also matters. The closer objects are, the stronger the gravitational pull between them. Sir Isaac Newton, a brilliant scientist, developed the law of universal gravitation. Legend has it that he was inspired by an apple falling from a tree. Newton realized that the same force that pulled the apple down also kept the moon in orbit around Earth. Newton's law states that every particle in the universe attracts every other particle. This force of attraction is what we call gravity. His work revolutionized our understanding of the universe, explaining why planets orbit stars and why we don't float away into space. Centuries later, Albert Einstein further refined our understanding of gravity with his theory of general relativity. Einstein proposed that gravity is not a force, but a curvature in the fabric of space-time caused by mass and energy. Imagine a bowling ball placed on a trampoline, causing a dip. Similarly, massive objects like stars and planets warp space-time around them. This warping influences the motion of other objects, like planets orbiting a star, following the curvature caused by the star's mass. Gravity plays a crucial role in our daily lives. It keeps our feet planted firmly on the ground, preventing us from floating away. It dictates how high we can jump and how objects fall. Without gravity, our world would be vastly different. Gravity also affects our bodies. It influences our bone density, muscle mass, and even the circulation of our blood. Astronauts who spend extended periods in space experiencing less gravity undergo physical changes and require rehabilitation upon their return to Earth. Section 5. Tides, the moon's gravitational pull. The gravitational pull of the moon causes tides on Earth. The moon's gravity pulls more strongly on the side of Earth facing it, causing a bulge of water. A corresponding bulge occurs on the opposite side as Earth is pulled away from the water. These bulges create high tides. Low tides occur in the areas between the bulges. The sun also plays a role in tides, but its effect is weaker due to its greater distance from Earth. Section 6. Cosmic Dance. Gravity in the universe. Gravity is the architect of the universe. It governs the motion of planets, stars, and galaxies. Gravity holds galaxies together in vast clusters and dictates the expansion of the universe itself. Without gravity, the universe as we know it would not exist. Stars and planets form from clouds of gas and dust drawn together by gravity. As the material collapses, it heats up, eventually igniting nuclear fusion in stars. Gravity keeps planets in orbit around stars, creating stable systems. Section 7. Gravity in action. Everyday examples. We witness the effects of gravity constantly in our everyday lives. When we drop a pen, gravity pulls it towards the ground. The water we pour into a glass is held there by gravity. Even the act of walking requires counteracting gravity's pull. Roller coasters offer a thrilling example of gravity at work. The initial climb up the hill builds potential energy. As the coaster plunges down, gravity converts that potential energy into kinetic energy, giving us the rush of the ride. Section 8. A world without gravity. Imagine a world without gravity. Objects would no longer fall down. We would float effortlessly, but so would everything else. There would be no atmosphere to breathe as gases would disperse into space. Planets would not orbit stars and stars would not cluster into galaxies. The universe would be a chaotic and dispersed soup of matter. Life as we know it would be impossible without gravity's organizing influence. Section 9. Fun facts about gravity. The strength of gravity is different on other planets. For example, you would weigh less on the moon because it has weaker gravity than Earth. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. Scientists are still trying to fully understand gravity and its relationship to other fundamental forces in the universe. Gravity is a fundamental force that shapes our world and the universe at large. From the fall of an apple to the cosmic dance of galaxies, gravity is an ever-present force that continues to fascinate and inspire scientific exploration.